Good day. Today we'll be looking at carbohydrates, focusing majorly on its meaning and classification. Carbohydrates, which are the major source of energy for every living cells, can be defined as polyhydroxyaldehyde or polyhydroxyketone. It is made up of three major elements, which is carbon and hydrogen and water, with the general molecular formula of CN into bracket H2O and N. Carbohydrates are oftentimes referred to as saccharide, which also means sugar, because it is soluble in water, sweet to taste, and crystalline in nature. Carbohydrates can be classified into three major groups based on their number of sugar units. And then we have monosaccharide, oligosaccharide, and polysaccharide. For monosaccharide, we have it as the simplest group of carbohydrates, which cannot be further hydrolyzed. That means it can't be broken down into smaller units. And they can either be an aldose or a ketone, that is a classification based on their functional group. They can either be an aldose sugar or a ketose sugar. An aldose meaning they have an aldehyde functional group, as you can see it on the slide, or a ketone functional group. And monosaccharide can also be classified based on the number of carbon atoms. We have triose sugars, tetrose sugars, pentose, hexose, and heptose. Here are a few examples of monosaccharides based on their number of carbon atoms and based on their functional group. And let's move to oligosaccharide. Oligo means few. That's a Greek word meaning few. And then it contains 2 to 10 monosaccharide molecules. And this can be further hydrolyzed. That means it can be broken down into simpler units. It's just 2 monosaccharide units combined together to form a single unit. 2 or more, I mean to say. So, oligosaccharide can further be divided into disaccharide and trisaccharide. Disaccharide meaning 2 monosaccharide units joined together by a glycosidic bond to form a single unit. By trisaccharide meaning 3 monosaccharide units combined together by a glycosidic bond to form a single unit. For example, we have sucrose, that's under disaccharide. We have sucrose. Sucrose is made up of 2 monosaccharide units, glucose and fructose. I'll give a short code there, GF. So you could just remember sucrose, GF. Just a way of remembering what you've read. And then we have lactose. Lactose is also made up of 2 monosaccharide units, which is glucose and galactose. Sucrose is also known as stable sugar, while lactose is known as milk sugar. Now moving on to trisaccharide, as I said earlier, it's 3 monosaccharide units joined together by a glycosidic bond to form a single unit. Now we have examples here. We have raffinose. Raffinose is made up of galactose, glucose, and fructose, while maltose is, and we also have an example called maltose, which is made up of 2 glucose units and a single unit of fructose. Raffinose is the sugar found in honey, while maltose is the raffinose is the sugar found in beans, while maltose is the sugar found in honey. Moving on, we'll have polysaccharide. Polysaccharide, when you hear the word poly, it means many. So these are many monosaccharide units joined together by a glycosidic bond. This is not just, like I said earlier, for oligosaccharide meaning few, there are 2 to 10 monosaccharide units joined together. But for polysaccharides are monosaccharide unit that is above 10, greater or above 10 monosaccharide unit joined together by a glycosidic bond to form a single unit. Polysaccharide can further be divided into two. We have homopolysaccharide and heteropolysaccharide. For homopolysaccharide, these are homo meaning the same, while hetero meaning different. Homopolysaccharide, that is the same monosaccharide unit joined together by a glycosidic bond to form a single unit, while heteropolysaccharide is different monosaccharide units coming together to form a single bond. And this is where we come to an end for carbohydrate and its classification. Bye.